In 2006, an AT&T technician discovered a door with no handle labeled 641A in an AT&T data center in San Francisco. This room housed a fiber optic splitter designed by AT&T and the NSA to intercept and analyze domestic and overseas internet traffic. In 2013, it was revealed that the National Security Agency, or the NSA, had been collecting bulk data on email traffic from millions of Americans. This disclosure validated the claims of a courageous whistleblower from AT&T named Mark Klein. Klein, a retired AT&T technician, blew the whistle in 2006, exposing how AT&T was cooperating with the NSA. He described secret rooms in various cities, including San Francisco, where internet traffic was split and sent to the government. This setup allowed the NSA to access email metadata, including sender and recipient addresses, IP addresses, and websites visited. How was this technically possible? It all comes down to a couple of key technologies: splitters and network packet analyzers. Splitters are devices that duplicate data signals. At AT&T, these were used to create two copies of internet traffic. One continued to its destination, while the other was sent to the NSA. This allowed the agency to access vast amounts of data without disrupting normal internet traffic. But just copying the data wasn't enough. The NSA needed to analyze it, and that's where the network packet analyzers come in. The internet is a packet-switched network, meaning data is broken into packets, each containing critical information like source and destination addresses. Analyzers inspect these packets to extract meaningful data, such as the content of emails or the browsing history of individuals. Yes, I tricked you to learn about how packets flow over a network. Let's break it down with the TCP/IP model. Let's think of a simple example when a web page loads in a browser. First, the user enters a URL into the browser's address bar. Second, the browser or client sends a DNS lookup request to the user's ISP to resolve the domain name to a numeric IP address. The ISP sends back the IP address of the requested domain to the user's browser. The browser establishes a TCP connection with the web server using the IP address, then it sends a TCP synchronized packet for requesting authentication. This is the first message in the three-way TCP handshake. The server responds with a synchronized acknowledgement packet. It authenticates itself and also requests authentication from the browser, the second in the TCP handshake. The browser sends back a TCP ACK packet, which is the third message in the TCP handshake, together with the first HTTP request. The TCP socket connection between the client and the server is established. Further messages can be sent without authentication. The server responds with one or more HTTP packets that deliver the HTML document for the requested page. In later round trips, it sends the CSS and JavaScript files, images, etc. An analyzer can dissect this information, providing detailed insights into the communication. Going back to our whistleblower, it sparked a significant legal and public debate about privacy and the government surveillance. The Electronic Frontier Foundation, or EFF, filed a lawsuit accusing the government of unlawfully siphoning Americans' communications, although Congress passed legislation to grant immunity to telecom companies like AT&T. This case underscores the delicate balance between national security and individual privacy. It also is a great opportunity for me to briefly introduce TCP/IP layers, protocols, packets, and internet communication overall.